Activity 2.3, Interpreting changes to the graph of a linear function. For the next festival, Marilyn's mom suggests that she still sells each t-shirt for $15, but should give away 3 t-shirts in a raffle. This new relationship, GT, is shown on the graph. Compare the two graphs. What do you notice? How do the graphs show the selling price per t-shirt remains the same? Well, remember in the last problem, we indicated with this green line that our slope was 15. We see with this second equation that it's also 15. So this slope represents the black line, which is the original. So for part A, it says, how do the graphs show the selling price per t-shirt remains the same? So here we stated that our slope was 15, and we can see that this line is parallel to the other one, and we can also calculate the slope as being 15 as well. So here we have the same slope. For part B, it says, determine and interpret the meaning of y equals g of 0 in terms of the graph in this scenario. Label the point on the graph. So if we look at this green line, and we look at where 0 is on the x-axis, we can see it's somewhere down there. We could probably guess to say a negative 45. It means that if no t-shirts were sold, Marilyn's potential earnings would be negative $45. This point does not make sense in terms of the situation. Part C, determine and interpret the meaning of GT equals 0 in terms of the graph in this scenario. Label the point on the graph. So if my output is 0, that means that's where it crosses the x-axis, so that's going to be 30. And it means that once Marilyn sells or gives away 3 t-shirts, her earnings are $0. She has no money to return to her mom. So remember, she's given away 3 t-shirts. Let's look at Michelle and Myra. Michelle and Myra each wrote an equation to describe the effect of giving away 3 t-shirts. Let's look at Michelle. Marilyn is giving away 3 t-shirts, so she has 3 fewer shirts to sell. 15 times t minus 3. Myra says the cost of giving away 3 t-shirts is $45. So 15t minus 45. Verify the two equations represent our equivalent. So let's talk about Michelle. Michelle says that g of t equals 15 times t minus 3. If I distribute in 15, that's going to give me 15t minus 15 times 3 gives me 45. Let's look at Myra. Myra said gt equals 15t minus 45. Notice after we simplified Michelle's equation, it was the same as Myra's. Verify the two equation represents are equivalent. And we did that. All you had to do was distribute in the 15. Number 3, how many t-shirts will Marilyn need to sell to earn $100? Use the graph in the equation. All right, so I'm going to go ahead and use Myra's equation here since it's already simplified for us. And honestly, you can use any one of these equations. So we want $100, and we need to figure out how many t-shirts to sell. All right, so I'm going to put 100 in for GT and solve for T. So let's come up here. So 100 equals 15t minus 45. I'm going to add 45 to both sides. That's going to give me 145 equals 15t. And that's 15 times t, so I want to divide by 15. So the number of t-shirts is 145 divided by 15, which is 9.6 repeating. So to make this make sense, we need to sell about 10 t-shirts. Keep in mind, she had to give away 3 t-shirts. So if we take 3 t-shirts away, our answer would be 7 t-shirts. So she needs to sell 7 t-shirts. Number 4, consider the expressions in the first 2 rows that define the quantities of the function and then the parts of each equation written by Michelle and Myra to complete the table. First, determine the unit of measure for each expression, then describe the contextual meaning and the mathematical meaning of each part. T represents the t-shirts. The contextual meaning is the number of t-shirts sold. And the mathematical meaning is your input, your domain. G of t is your profit, your dollars, your potential earnings, which is your output, $15 represents the dollar per shirt or price per shirt. And again, that's the selling price per shirt. And this is called your slope or your rate of change. t minus 3 is your t-shirts. Number of t-shirts that need to be sold, not counting the 3 free ones. And this is the input minus the constant. $15T are your dollars. And this is your earnings per t-shirt. And this is your rate times the input. Negative 45 are the dollars not being earned, the money that's not being earned. Basically the 3 t-shirts you're giving away. And this is your y-intercept. Linear functions that Michelle and Myra each wrote are equivalent. However, they are written in different forms. The linear function gt equals 15 times t minus 3 is written in the factored form, and gt 15t minus 45 is written in the general form. A linear function can also be referred to as a polynomial function. A polynomial is a mathematical expression involving the sum of powers in one or more variables multiplied by coefficients. The degree of a polynomial is the greatest variable exponent in the expression. The leading coefficient of a polynomial is the numeric coefficient of the term in the greatest power. So here, when we talk about constant, you've got px equals 7. So it is to the 0 degree. Think about having 7 times x to the 0 power. So we're looking at the exponent of x. Here in this next example, we have 2 times x. And so when you don't see an exponent, it's to the 1st degree. In the next one, you have your highest exponent is x squared. We ignore this one because it's not the highest, so we go with the highest exponent. So that is quadratic. In the last one, we have an exponent that is raised to the 3rd power, so it's cubic. So when you don't have a variable, it's constant. When you do have a variable and it's to the 1st power, it's linear. When it's the variable to the 2nd power, it's quadratic, and to the 3rd power, it's cubic. The structure of each linear function tells you important information about the graph. Let's consider the general form of the linear function f of x equals ax plus m, where a and b are real numbers and a does not equal 0. In this form, the a value is the leading coefficient, which describes the steepness and direction of the line. The b value describes the y-intercept. You know the form y equals mx plus b as slope-intercept form, where m represents the slope and b represents the y-intercept. Notice that the general form has the same structure. The general form shows that a linear equation is a polynomial of degree 1. You will learn more about polynomials as you progress through this high school mathematics. Number 5. Consider the general form of the linear function gt. Label A on the graph. So A is the same thing as talking about the slope. So I could use rise over run. I could pick out 2 points, but I want to pick out where it crosses in the corner. If you notice here, the X goes by 1. We're still talking about the t-shirts. My Y is 10. So I'm going up 10, 20, 30. So my rise is 30. My run is 2. And so that's 15. So my slope is this triangle on the graph, which is 15. Label B on the graph. B is your y-intercept. It's where it crosses the graph on your y-axis. So there's your y-intercept. That's B, which we said was negative 45. Next, consider the factored form of the linear function f of x equals a times x minus c, where a and c are real numbers and a does not equal 0. When a polynomial is in the factored form, the value of x makes the factor x minus c equal to 0 is the x-intercept. This value is called the zero of the function. A zero of the function is a real number that makes the value of the function equal to 0, or f of x equals 0. You can set x minus c equal to 0 and determine the point where the graph crosses the x-axis. Consider the factored form of the linear function gt. Label A on the graph. So if we take the factored form, g of t equals 15 times t minus 3, we're going to have the same slope. A represents 15. It's the same triangle that we did previous. Now C is my x-intercept. It's where it crosses the x-axis. Notice my x-intercept is negative 3. So if we go up here to the graph, we would have the same triangle represented A as 15, and my x-intercept would be 0 and 3. That would be my C. Number 7, what is the zero of GT? So if we take that equation, and we set it equal to 0, so GT equals 15 times t minus 3. And instead of GT, we're setting it equal to 0. And we're solving for t. So this is 15 times. So I'm going to divide both sides by 15. So that still gives me 0. T minus 3. Add 3 to both sides. And notice that your t is 3. That is your x-intercept when you set it equal to 0. So 3 and 0 is your x-intercept. Activity 2.4, interpreting more changes to the graph of the linear function. The next festival that Marilyn is attending charges $35 fee to rent a booth. She's still selling her mom t-shirts for $15 each and giving away 3 in a raffle. The graph shows the new relationship FT. Consider the relationship between the graphs of GT and FT. How do the graphs show that the selling price per t-shirt remains the same? So, here again, we're showing the same slope, rise over run, and so therefore we have the same selling price. So the slope is the same. The rate of change is the same. $15 is still the same. Part B. How did the new booth fee of $35 change the graph? So now that we have to give away 3 t-shirts, we also have to pay $35 for the booth fee. So remember, we had $45 that we were giving away. Now we have a $35 that we also need to pay up front. So that would be $80 that we are having to deduct from our earnings. So here we have negative 80. So that's where we're starting out. We're starting out owing negative 80. Part C, how many t-shirts will Marilyn need to sell before she will have any money to return to her mom? All right, so let's look at the graph. Here we're going to look at the green line. Remember, she's starting out in the hole with $80. And X represents the number of t-shirts. So how many t-shirts? It looks like right here, we're going to break even. Right here, we're going to cross over, and at 6 t-shirts, we'll be able to give Mom $10. So for part C, we can go with 6 or more t-shirts. Part D, how many t-shirts will Marilyn need to sell to earn $100? So we want to earn $100. So over here on the graph, here is our profit. And where is the green line going to hit? It looks like at 12 t-shirts. We need to sell 12 t-shirts to get a profit of $100. Number 2, consider the relationship between the equations gt and ft. Write the function ft in terms of gt. So let's look at these two equations. We've got gt, which is 15 times t minus 3, and ft, which we discovered has the same slope. However, we're starting down at a negative 80 for our y-intercept. And I could simplify this to be 15t minus 45. And to put this in terms of ft, ft equals gt minus $35 more. ft equals gt minus $35 more. So that was number 2, part A. ft equals gt minus 35. Part B, rewrite ft in general form, then describe how the A and the B values are graphed. Well, gt is 15t minus 45. Then we're going to subtract another 35. So ft equals 15t minus 80. So A is our slope. A was our triangle of 15. B is our new y-intercept of negative 80. Part C, rewrite ft in factored form, use a fraction to represent the c value, then describe how the a and c values are represented on the graph. All right, so I'm going to factor out and what it means to factor out is what can I take away from 15 and 80, and what I'm going to do is I know that I'm going to take away the slope, so I'm going to divide out the 15, and that's going to be a t. So the factored form is the reverse of the distributive property. So 80 divided by 15 gives me 16 over 3. So 16 over 3, or 5 1/3, is my x-intercept. That's my C. 15 is still my A. Let's talk the talk. Reading between the lines. Complete each I can statement using always, sometimes, or never. Suppose you are given a dependent value and need to calculate an independent value of the linear function. I can blank use a table to approximate the value. Yes, always. Part B. I can blank use a table to calculate an exact value. Sometimes. Part C. I can blank use a graph to determine approximate value. Always. I can blank use a graph to calculate an exact value. Sometimes. E, I can blank use an equation to determine the approximate value. Always. I can blank use an equation to calculate an exact value. Always. Number 2, write the function that models each table of values, then evaluate the function for each independent and dependent value. So first I need the function, so let's calculate the slope. So I've got 5 minus 20, 5 minus negative 20 gives me 25, and it looks like I'm increasing by 1. So my slope is going to be 25x, and then I got to figure out where it's going to cross the y-intercept. So if I use one of these points, so I'm going to come over here, y equals mx plus b, and I'm going to use my 5 for the y. My slope I said was 25. And I'm going to plug in 2 for x, and I'm going to solve for b. So 2 times 25 gives me 50. Subtract 50 from both sides. And b actually gives me negative 45. So there's the equation that I'm going to use. Now if I plug in 12, 25 times 12, take away 45. So 25 times 12 minus 45 gives me 255. Here I'm given the output of negative 145. So I'm going to do this a little different. So remember, f of x equals 25x minus 45. So instead of putting a number in for x, I'm going to put a number in for f of x. And they're telling me that I need to put in negative 145. And I'm going to solve for my input. So 25x minus 45. So I'm going to solve for x. That means I'm going to add 45 to both sides. And that gives me negative 100 equals 25x. Then divide both sides by 25. And x simplifies or solves down to be negative 4. So that is my input. So f of negative 4 equals negative 145. Part B. Here I've got a new function. So let's go through the process again. Calculate your slope. 6 minus 18 gives you negative 12. Here it looks like I'm increasing by 2, so 3 minus 1 gives me 2. Negative 12 divided by 2 gives me negative 6. So my slope is going to be negative 6. And I'm going to come over here to the side here and calculate the slope-intercept form. And let's use 3 and 6. So 6 in for y. Slope is negative 6. 3 for x. Calculate the y-intercept. Negative 3 times 3 gives us negative 18. Add 18 to both sides. 18 and 6 gives me 24. So my y-intercept is 24. So I've got negative 6x plus 24 as my equation. And then I'm going to plug in negative 9. So negative 6 times negative 9 plus 24. Negative 6 times negative 9 plus 24 gives me 78 as my output. Here they're giving me my output of negative 54. So we had g of x equals negative 6x minus, plus 24. They're giving me the output of negative 54, and I need to solve for x. So I'm going to subtract 24 from both sides. Negative 54 and negative 24 gives me a negative 78. Divide both sides by negative 6. And negative 78 divided by negative 6 gives me a positive 13 as my input. So g of 13 gives me negative 54 as my output. Number 3, complete the graphic organizer located at the end of this lesson for linear functions f of x equals 2x minus 8. Write f of x in general form, then describe the information given in this form. All right, so we're going to look at the equation f of x equals 2x minus 8. That's actually the general form, so that's going to go here. Where you have your slope is 2, and your y-intercept is negative 8. Your factored form, f of x equals, we're going to pull the 2 out, which is our slope, x minus 4. So here, my slope is still 2, but what they're giving us is the x-intercept. My x-intercept is going to be 4. It's going to be opposite of what's going to be in the parentheses. And then for the bottom part, you've got your graph. And if we graph this, remember that my x-intercept was 4, and my y-intercept was -8. And I can construct a line going through those 2 points. And I can still show that my slope is rise over run, which is 2, up 2 over 1. Table of values. For this function, when x is, let's say, -1, and if I plug in -1 for x, 2 times -1, take away 8 will be -2, minus 8 will be -10. If I plug in 0, remember that's going to be your y-intercept, -8. If I plug in 1, that's going to be 2 minus 8, which gives me -6. And if I plug in 2 here, that gives me 4 minus 8, which is -4.